Welcome to the walkthrough for Assignment 1B in my CS Scalable Microservices course in the spring of 2024. The purpose of the second part of this two-part assignment is to acquaint you with developing synchronous microservices with Spring WebMVC, Java structured concurrency, and Java regular expressions. In this assignment, you'll evolve the synchronous microservice that used Spring WebMVC from Assignment 1A to use the structured task scope shutdown and failure class to concurrently return lists of objects containing information about movies from a movie recommender system we'll use throughout this course. The code you write for this assignment does not have a GUI and runs as a Spring application with an automated test program. Please feel free to use this test program to help debug your solution. The following resources may be helpful in completing this assignment. An overview of Java structured concurrency appears here, an overview of Java regular expressions appears here, and videos giving an overview of Java structured concurrency appear here. Naturally, we'll cover this material in class, which will be available in my YouTube playlist. The Movies microservice is packaged as a project using IntelliJ. This app is written in Java and demonstrates various Spring WebMVC and Java structured concurrency features. For the purposes of Assignment 1B, however, you only need to be aware of the following directories. Recommender Movies, which contains the skeletons you need to fill in, is described below, and Movies Source Test, which is a set of unit tests that exercise the features you're implementing to evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you'll need to use the provided IntelliJ project. You can run this project by clicking the green arrow next to the Movie Test drop-down menu in the IntelliJ IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Do not change the overall structure of the skeleton. Just fill in the to-do tasks, and do not delete the to-do markers. If you delete the to-do markers, your code will not be reviewed. In particular, you need to finish implementing the to-do task for this assignment in the following files and folders. moviescontroller.java, where you need to complete the to-do task in various fields and methods to define endpoint handler methods that return lists of objects containing information about movies. moviesservice.java, where you'll need to complete the to-do tasks in various fields and methods called by the movies controller that uses the Java structured concurrency and Java sequential streams mechanisms to return lists of objects containing information about movies. You'll also use Java regular expressions to get more precise control over searches. In the serverbeans.java file, you'll need to complete the to-do tasks and factor methods, known as beans, that can be injected into Java classes using the Spring auto-wired annotation to load a dataset containing movie titles and descriptive vectors. And finally, in movies sync proxy.java, you'll need to complete the to-do task to implement proxies to various endpoints in the movies microservice. You'll also need to use Java regular expressions to get more precise control over searches. As with assignment 1A, your solution should use no loops or if-else statements in this assignment, and instead use Java functional programming features, including lambda expressions, method references, and sequential stream aggregate operations, along with Java's structured concurrency mechanisms. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. Skeleton code from this assignment is available here in my GitHub repository. Please set up your GitLab account, pull the skeleton code into your repository, read it carefully, and complete the to-do markers. The unit tests in the Movies Source Test folder are provided to increase our collective confidence that your implementation is working as expected. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the unit test to detect problems in your code. Assignment 1B is designed to acquaint you with developing synchronous microservices using Spring WebMVC and Java structured concurrency. The skeletons and unit tests are subtle, though you don't need to understand them all to complete your solution. This assignment is much more complicated than Assignment 1A. So please start early and ask questions in class, office hours, and on the discussion forums to ensure you complete this assignment successfully. Now that we've walked through the specification for Assignment 1B, let's go ahead and take a look at the skeletons, starting with the test skeletons you have to fill in to provide the movies sync proxy. If you open this file, you'll see that this class provides proxies to various endpoints in the movies microservice. This proxy file is very similar to the one you used for Assignment 1A, with a little difference to add in support for regular expression searching. So let's go ahead and take a look at this particular code. So there's a get movies proxy where you have to add the URI component builder logic to create a URI to the all movies endpoint of the movies microservice. And make sure you fill in this code and use the proper constants. Don't fill in the magic numbers here, magic strings, because it's easy to get them confused as changes occur. Then next, you go ahead and use the web utils make get request list method and the mMovies REST template to get a list of all the movies from the movie microservice. And once again, you fill in the code to do this. Please make sure that you format your code properly so things don't go running off the right-hand side of the screen. I think most people got this particular proxy correct for assignment 1A, so it shouldn't be hard for assignment 1B. Now let's move on to search movies. Things have changed a bit here. We're actually taking in a regular expression query instead of just a string. And so you'll have to do a little bit more encoding here. So first you'll use the URI component builder to create a URI to the search endpoint of the movies microservice. And this regular expression query should be encoded using the webutils encode query method, which is over here in the utils folder under webutils. So it can be encoded prior to being used to construct the URI. And we'll show an example in class that will illustrate how to do this, but make sure you do that. And then down here, you fill in the code replacing null with the actual implementation. And once again, you'll also fill in the code to make the request. Notice also that because we're doing this regular expression as a parameter, you'll need to add that appropriately using the from path method. And as always, take a look at the Barra quotes example to see how to do this. Coming down here to the search movies proxy, you see this takes a list of regular expression queries strings. And so once again, you'll use the URI component builder to make a URI that's going to search the endpoints for a list of queries. And you'll need to, again, convert the regex queries into a string after you encode them using the webutils encode query method. So that's going to take a little doing, but you can look at the example we talked about in class to get a hint as how to do this. Note here, you'll also have to use that method that's called list to string that's in webutils in order to be able to do the appropriate encoding too. So you fill in this null with the proper code, and then once again, you'll go ahead and use the make get request list method in the mMovies REST template to make the request to the server. Once again, make sure you write this code in a way that formats it properly so it's easy to read, and also comment your code thoroughly, just like I do all my examples. So let's now go ahead and move out of the test folder and let's go take a look at the main folder. So over here, things are similar as we did with assignment 1A. I changed the name of this file from components.java to serverbeans.java because I think it's a bit more descriptive. This code should be essentially identical to what you had, however, for assignment 1A. Just make sure you do it properly. Also make sure that you use Java 8 logic, or rather modern Java functional programming with Java streams here, rather than using loops or if statements and other kinds of things like that. Let's take a look over here now in the server folder. You can see there's two files you have to fill in. First is movies controller, and this will look very similar to what you had for assignment 1A, with a couple of exceptions. We're passing in regular expression strings or regular expression lists of strings here. Won't look a whole lot different in terms of what it looks like. You just want to name them differently because otherwise you won't get the appropriate matching from the proxies that you use to send the data over. So make sure you match up your client and server code names with respect to what you have for the proxies. But otherwise, very similar to what you had in assignment 1A. So finally, we turn our attention to movies service. This is where the bulk of the changes are enabled relative to assignment 1A. So you take a look here, you'll have to add the appropriate annotation to make sure that this is auto-wired. That should be pretty straightforward by now. The get movies method, very straightforward. I think pretty much everybody got that right because it's kind of one-liner, so it's really simple. If you look down here, things get more interesting with search. In fact, search is actually just going to do something very clever where you're going to take the string here, turn that string into a list, and then simply forward it to the search method down below that takes a list of strings. So that'll make that implementation a little bit more concise than what you had in assignment 1A, and thereby reusing more code. Finally, we get into the search method that takes a list of regular expression queries. And this is quite different from assignment 1A because we're actually going to use Java structured concurrency here. And we're going to use structured concurrency to locate all the movies whose IDs match the list of regular expression queries that are passed in here. And this is going to get returned back as a list of matching movie objects. So the first thing you're going to do is you're going to convert the list of regular expression queries into a list of pattern objects. This list of pattern objects will be created by a factory method that's defined down here in skeleton forms. If you come down here, you can see there's a method called make pattern list. And it's going to take in that list of regular expression queries as a string. And in this implementation, which you have to provide, you'll use a Java sequential stream to do the following steps. You'll convert the list of strings to a stream of strings. That's very easy. Then you'll decode each regular expression, and you can do that using the technique that we'll talk about from an example in class. Then you'll go ahead and compile the regular expression patterns in a way that will ignore case. They'll be case insensitive. We'll also talk about that in class as well and show an example to do that. And then finally, you convert the resulting stream of compiled regular expressions that ignore case into a list, and you return that list. So that's what you put here instead of return null. So popping back up here, you can see once we've created this pattern list, then we're going to go into the body of the method. And the body of the method is going to have a try with the resources block where you're going to create a new structured task scope that shuts down on failure. And so you'll have to write the code here that does that. We'll obviously talk about that in class. It's pretty straightforward. And then within this block, then we're going to do a couple things. The first thing we're going to do is we're going to call a helper method that will concurrently get a list of all movie objects that match the pattern list. And so if you take a look down here, you can see there's a method called getMatches, and it takes the pattern list and it takes that scope we talked about before, and it uses a Java sequential stream that does the following steps. It converts the list of patterns to a stream, and then it's going to call a helper method, which we'll look at in a second, that uses the Java structured task scope parameter, the shutdown on failure parameter that's passed in here, to concurrently determine if the movie title matches with each regular expression query. And then the final thing we'll do is we'll convert that stream to a list and return that list. And you can see here it's going to be a list of futures to lists of movies. So let's go ahead and take a look at that helper method, which is defined right here. It's called find matches. You can see it takes a pattern and a scope, and it'll use the scope parameter rather, to determine if the pattern matches any movie objects in M movies, which is that auto-wired list of all the movies, as follows. You'll use the scope parameter to create a virtual thread to perform processing concurrently. You'll learn how to do that when we look at the videos for doing shutdown on failure processing with Java's structured concurrency mechanisms. You'll then convert the M movies list to a stream within that new virtual thread. You'll call another helper method and only keep movie objects that match the pattern. So that should be a hint. You're going to filter them, only keep stuff that matches. And then you're going to convert that stream of any matches into a list and return that list as the result of this particular method. And it's called, it'll be a future to a list of movies because we're passing in the scope. And that's what you do when you use scope to fork off a virtual thread. Let's go take a look at the method you'll call here, this other helper method, yet another helper method called match. And this takes in a pattern and a movie, and it checks to see if there's a match between the pattern and the movie by performing the following steps. So you'll create a matcher that will be used to check the movie's title, and you'll then call a method on that matcher that will return true if there's a match. Otherwise, it'll return false. And again, we will take a look at an example in class that illustrates how to convert or how to connect a pattern to a matcher and then use a method on the matcher to find out whether there's a match or not. So let's pop back up here, back over to this structured task scope area. And you can see after this call returns, all those calls will take place in the background. So we're going to have to call a barrier synchronizer that will wait for all the tasks to complete. And of course, when you watch the videos about the structured task scope and shutdown on failure and so on, you'll know how to do that. Barrier synchronization, just like the example we look at in class. You'll also throw an exception if any of the tasks fail. You'll know how to learn how to do that as well. And then the final thing you'll do here is you'll replace return null with another helper method that will concatenate all the matches and return a list of movie objects that matched at least one client query. So that method is defined way down here at the bottom. That's called concat matches. You can see it takes this list of futures to lists of movies. And then we're going to use a Java sequential stream to do the following steps. And this is kind of subtle. We're going to convert the list of futures to lists of movies, which is this parameter that's passed in, to a stream of lists of movie objects. And to do that, you want to go over here and take a look at the future utils helper class. And you'll see that there's a method here called futures to list. So you'll have to figure out how to call that. It's pretty simple to call, but it does some really cool things. on your behalf. And then you'll go ahead and use another method. This will be an intermediate operation on Java streams that flattens the stream of list objects into a single stream. So you'll have a single stream of movies. And the other thing that's cool about this method that flattens things is it eliminates any empty list objects that might have occurred. We will also, of course, talk about how to use that method in an example we'll look at in class. And then the final thing you do here is you'll convert the stream to a list of movie objects that are then returned from the method. And that's what gets returned back up here. So as you can see, there's a number of steps. The driving force here is in this search method, which is the one that uses the structured task mechanisms and structured concurrency within a try with resources block. And then you have to basically fill in the logic and then implement those helper methods along the way. As we'll see, there will be unit tests to help give you more guidance on this. But this is a complicated piece of code. It's actually very cool. It's very canonical. It's often write code like this using Java structured concurrency. And it'll give you a much deeper understanding of how to write that type of concurrent software using this brand new mechanism in Java 19 and beyond. Now that we've walked through the specifications and the skeletons, let's go ahead and show how to run the unit tests. If you go and click on the test folder and then right-click on Run the test, you can either run it that way by clicking here, or you can also load up the little tab at the top so it says Movies Tests and click there. Both ways should get you the same result. So as you can see, things are up and running. If you take a look here at the build portion of the tab here at the bottom of your IntelliJ project, you can see it's building everything. And as things build, they will give you warnings if you have any problems with compilation errors. Assuming everything works fine, then let's go back over here to run. And you can see here that all the tests ran. Currently, we have a number of tests here. We're going to be adding more tests. This is something you'll have to get accustomed to, updating your repository in a few days as we add some more tests. But this should be enough to get you started. So as you can see, some of the tests here are the same black box tests that we had before, or similar black box tests that we had before. Those tests to make sure that your code is returning the results from the server, from the microservice that the client expects. And then there's also a bunch of white box tests that go through and analyze your code in various ways to make sure you're doing the calls properly. In all cases, you should strive to get nothing but green check marks. If something goes wrong, then you'll get a warning or an error with a little yellow or red symbol instead of a green check mark. So make sure that everything works. Also, remember when you're done, go ahead and take a screenshot of your tests. You can see I just did that here. And then go ahead and add that screenshot to the assignment 1B folder so I can make sure that you've actually run the tests. Incidentally, this is what the output looks like if you run the unit tests on the skeletons, indicating what happens when the methods aren't implemented properly. Of course, the implementations of the skeletons will not be correct because they're pretty much empty. But you can see that they'll fail in all kinds of spectacular ways, indicated by red. Sometimes you get yellow failures, but in general, if the failures are either red or yellow, you need to fix them. If you click on these test results, it'll also tell you what happens to some extent. They're not there to give away all the solutions, but it'll at least give you a sense of what might be going wrong. So please get in the habit of running the tests and taking a careful look at the output to make sure you understand what's going on and can correct any problems that occur. As always, feel free to come to office hours if you have any questions and/or ask questions in class or on Piazza. So that concludes our walkthrough of the specification, skeletons, and tests for assignment 1B. This is a much more complicated assignment than assignment 1A, so please make sure you get started early. And if you run into any problems, make sure you come to office hours and/or ask questions in Piazza and/or ask questions in class. So don't wait to the last minute, and make sure that you follow the deadlines so that your code is properly reviewed and going to be graded at the end.